Hey, all you whiskey fans, have you ever done a distillery tour and the distillers or the tour guide kept talking about the condenser temperature and why it's important? Did it make sense to you? Did they give you enough information? Or are you a home distiller or hobby distiller that's looking to learn a little bit more about why it's important to have certain temperatures and what do those temperatures do for your distillate and your end final product? If you have these questions or would like to learn more, then this video is for you. Grab a glass and let's talk about it. So for starters, what is a condenser? A condenser, and this is a very simple, very small one. This is kind of, I guess I'd call it a shotgun condenser because it kind of looks like a shotgun. There's other ones which are of course longer. And these are pretty typical to what you would find in a home distilling kit, but not necessarily in a distillery. Why? It's not very effective. It's very simple. Essentially, you have two sources of water. One little hose would connect here to let water in, and one here to let water out. And then inside this shotgun tube, essentially you have this outside container. And then inside, at the very top there, you have where the distillate or the steam at the bottom gets cooked, becomes steam, and tries to exit, and then has a little tube inside which is surrounded by cold water on the outside. This exchange of thermal temperature reduces the temperature of the steam and reconverts it back into a liquid. And that liquid will then come off the tip of the whiskey. Easy. Makes sense. I need water to come in and water to come out for my distillate to not be steam as it exits, because that's very dangerous. Where does this get more complicated? For starters, or what temperature do you require at the very least for the whiskey to, or the steam at this point, the ethanol which is now distilled, to turn into a liquid? Theoretically, anything less than the temperature of the steam in the still. I say theoretically because this is heavily unrecommended. Not by me, and I don't think by anybody else in the industry, but there are some stills out there which are naturally cooled. Maybe the piping is very long and it's very cold outside, and you trust that this alone will convert all of your steam, all of your distillate back into a liquid. Very, very dangerous. I don't recommend it at all, because if any steam is being lost, that's potential whiskey that you're losing, or distillate, but even more importantly, it is extremely flammable. So you want to make sure that the water that you have in your condenser, so the temperature which is in the condenser here, is somewhere in between 10 to 15 degrees Celsius or 50 to 60 degrees Fahrenheit, like a basic rule of thumb. However, it gets even more complicated than that, because again, this is a spectrum, this is a scope. And you have the ability to set up and use hotter or colder. And also with the different types of condensers that you have, the result of what you get is different. Ideally, or let's say some basic rule of thumbs, you want to have, and this is always the way you hook it up. So if you have a condenser, you have the coldest water coming in at the bottom and the warmer exiting at the top. The reason for this is usually in distillation, you want a slow and long conversion of that steam to convert back and condensate back into a liquid. You do not want to shock condense it. That would happen, for instance, if I had cold water coming at the top, and this cold water is directly coming into contact with my distillate, my steam, and right away being shock turned back into a liquid. Theoretically, it's very efficient, but for flavor, it's not recommended. Why? Because we're talking about different components which have converted into a steam or a vapor form. These different components can be thicker and they can be thinner. And how they convert is heavily affected by the amount of temperature and the shock that they absorb and go through. You might have heard the term in distillation, long and slow. This is actually referring to the heat that you apply at the pot, which is not attached here, but that heat. So you don't want, let's say it's on a scale of 1 to 10, 1 being the lowest and just on, and 10 being high, you would probably run your still at like 3 to 4 if you followed this way of thinking. It's kind of the same for the condensing. You don't want to turn the power all the way up to 10 and have a lot of energy being pushed into your still. Again, it could be dangerous, but you also then start to burn and to really force a lot of these components to be converted into steam. Not always a good thing, probably never a good thing. It's the same for the condensation. You want the temperature at the very top of the condenser to be warmer than the temperature at the very bottom. And you want this slow conversion as the steam enters and slowly to turn into a liquid as it comes down. This way, the components in your steam, in the distillate, are not being shocked and are not being forced. Let's give some crazy examples here. For instance, what happens if you are running your still, or your condenser, sorry, hot? This means that if I'd mentioned before, you can be anywhere from 10 to 15, you're running at 15 to maybe 18 degrees Celsius at the coldest point. Well, what happens is you're still going to probably convert everything. I mean, the steam inside the still is relatively hot, so you will convert everything back into a liquid form. But what happens are some of those heavier components might be lost, and they might not have enough time or the right temperature to convert back into a liquid. What really disappoints me, or not disappoints, but I really try to stay away from my condenser ever getting too hot, is that you start to lose the oilier components, those heavier components in your distillate. And this is something that I personally really like and enjoy. I like that heaviness. I like that oily mouthfeel. So I want to make sure that my condenser never gets too hot, and ideally never gets hotter than 15 degrees Celsius. Now, on the reverse side of it, what happens if you're shocking it and you're getting it too cold right away? Well, what starts to happen is, I mean, you might have seen a column still or a refractor, where at the very top of your still you have kind of like a cold spot, and as the steam tries to exit the still, it gets cold again and then starts to create reflux, and that steam in the pot turns back into a liquid and goes back down and then has to work its way up again. This forces or makes the still start to be almost like a column still, like a second distillation, if you will. And it means that your distillate has to become finer and finer before it leaves the pot. But also this means that essentially you start to lose some of the components that you might want to be keeping, especially some of those like not so heavier components. So it's a balancing act. And again, it's for a distiller to decide. Sometimes you might find that because of the natural flowing water of the stream and that water that you are using in your distillery, the temperature varies in your condenser. And then you might find it more beneficial also, especially if you have larger stills, to have different types of condensers. So the temperature of your condenser is very important. And it's so important that it can actually help you dramatically influence your white dog, your new make, by the temperature at which you run and operate. It plays a huge role in how fine or how oily and heavy your distillate is at the end. For me, it's something that I spend a lot of attention on with our March distilling whiskey back there, because I like a heavier, fuller whiskey. And especially at the new make level, you really need to play and have a huge control over this to make sure that the spirit is as much as possible where you want it to be at its first step and early distillations. So is the condenser temperature important? 100%. It's dangerous if you're doing it wrong, so you really want to get it right. But even in that scope of being right, it can make a huge impact and it'll change a lot of what your final product is and how it tastes. So it's very important. In my opinion, personally, I run it cold because I like heavy, but if you like finer whiskeys and finer distillates, you can run it a little bit hotter and see how this affects and changes your final product. With that, next time you do a distillery tour, think about it, ask the question, learn about the condenser. It is just as important as the pot still itself. However, you almost never see it. With that, cheers to you, your next glass of whiskey, oily or fine. Bye now.